Hi everyone. In this video we will be talking about something called limits at infinity. You have seen this idea before in Math 140. The goal for this week and the following will be to put together all of our calculus knowledge in order to learn how to plot the graph of a function. Now, limits at infinity. So first of all, let's break this down into some of the ideas that we have seen before. Recall that this particular notation means the limit of f of x as x approaches a is L. Technically, this means that we also need that the left hand limit equal the right hand limit. So for example, if you look at a graph, if you have a continuous function, then it's easy. It just means that whether you come in from the left or you come in from the right, you're approaching the value L. But you could also have a discontinuous function, and this is still valid because again, it says that if you're coming in from the left and you're coming in from the right, your best guess for what would happen or what happens at x equals a is still L, and it still agrees on both sides. Therefore, when we say limits at infinity, right, it means we want to look at limit as x goes to infinity of f of x, and the other kind of limit, which is x goes to negative infinity. So in a sense, what we are trying to do is we are asking the question, what happens at the endpoints of the number line? So we're trying to find what happens at the end of these functions, at the two ends of these functions. Now there are, once again, there are three possibilities. There are three things that can happen. And what these three things are, they're basically, if I give you a graph and I ask you, draw something, right? And you only have certain choices for what happens at the endpoints. For example, you could have a graph that keeps going up, right? So this goes to infinity. You could draw a graph which sort of plateaus, right? It gets to a plateau. That's a possible case. And the third case is, well, some weird stuff happens, like nothing can be said. So these are the three possibilities that can happen, in which the first and the last are not that interesting. This one is interesting because this line which forms the plateau is called a horizontal asymptote, and that you have seen before in Math 140. So let's add a definition to this. The line y equals L is a horizontal asymptote to the function y equals f of x if limit x goes to infinity of f of x equals L, or limit x goes to negative infinity of f of x equals L. Okay, so one of those things happen. Now, what does that mean? Does it mean pictorially? it means here is your L, suppose it's positive, then whatever your function does on this side, it can never cross the line L. Never crosses L on the right. Right? So this would be an example where x goes to positive infinity of the function is L. You could also have an example like that. Never crosses L on the left. So limit x going to negative infinity, f of x equals L. Now, important thing here is that it could cross it on the right, and here it could cross on the left. Sorry, it could cross on the left in the first, and it could cross on the right on the second. Right? As long as we are using the right notation. So just because it's a horizontal asymptote doesn't mean it cannot cross. It just means it wherever there is an asymptote, it cannot cross, like at infinity. And then the third case is if it's an asymptote in both directions, right? So it never crosses L on both sides. So in this case, both the limits at infinity and the limit at negative infinity is some finite number L. For definition, it's not an and, it's an or condition, meaning that as long as one of those is satisfied, it is still a horizontal asymptote, which means you could have a picture that looks like 1, you could have a picture that looks like 2, and you could have a picture that looks like 3. Let's look at some familiar examples. One of the most familiar one we have seen is 1 over x, and we know how to evaluate these limits. As x goes to infinity of this function, we have x goes to infinity of 1 over x, which is 1 over a large number, which is almost 0. So this limit is 0. Limit x going to negative infinity is limit x going to negative infinity over x. This is 1 over a negative large number, so it's close to 0 again, but from the negative side. So this gives us that y equals 0 is a horizontal asymptote. And in this case, it's a horizontal asymptote on both sides. And we know that because the graph of 1 over x looks like that. And that is the line y equals 0. It is the x-axis. So the x-axis forms a horizontal asymptote. And if you shift this graph to the right or left, your horizontal asymptote is not going to change. But if you shift this function up and down, the horizontal asymptote will change. Now we can generalize this. We can say that if r is a rational number and x to the power r is defined, what does that mean? Well, for example, if r is half, then x cannot, its domain will not have negative numbers. In the domain, then then the limit as x goes to infinity of 1 over x to the power r is always 0. And so is the limit as x goes to negative infinity of 1 over x to the power r. Okay, that's because as your input becomes large positive, this is a 1 over a larger number. Or it could, if it's a square root, it would not be larger than it would, but it would still go to infinity because you can plug in as big a number as you want. Similarly, if as x goes to negative infinity, this is going to happen. It's going to go to 0 again. Now this is an important result, and we are going to use this um, to get some results about some general stuff. Okay, so in the next video I will discuss some general rational functions.